Section 3.4 is going to talk about operations and composition of functions. So we're taking that function notation, we talked about it, and putting them together in different ways. So one thing you might see is something like this, where it says f of x plus g of x, or f plus g of x. Those both mean the same thing. They mean take whatever value they give you for x, plug them into each, and then add them together. For example, if this is our f of x, and this is our g of x, and we're doing f plus g of 1, we're going to start by plugging 1 into f. So we would do 1 squared plus 1, based on the equation, which is 1 plus 1 or 2. Then we would do g of 1, which would be 3 times 1 plus 5, or 3 plus 5, which is 8. Then we add those together. So 2 plus 8 is 10. You might see one of these two, which is the same thing. It's just telling you to subtract your answers. So f of negative 3 would be negative 3 squared plus 1, or 9 plus 1, which is 10. Then if we did g of negative 3, we would be doing 3 times negative 3 plus 5, which gives us negative 9 plus 5, or negative 4. Then we subtract our answers. So 10 minus negative 4 is 14. For ones like this, just make sure you pay attention to the order of what's first so that when you subtract, you get the right sign. The next thing you're going to see is this multiplying. So they could be right next to each other, like the top or the bottom. But again, if they give us a number, it's the same thing. So f of 5 would be 5 squared plus 1, which is 25 plus 1, or 26. Then we do g of 5, which is 3 times 5, which is 15, plus 5 is 20. And then we multiply those together. So 26 times 20 gives us 520. The last one we're going to see for now is dividing. And it looks like there's more just because we could make it a fraction or we could use division symbol, but they're all saying the same thing. So if I plug in 0 for f, we're saying 0 squared plus 1 is 0 plus 1, or 1. Then if you say g of 0, we're getting 3 times 0 plus 5 equals 0 plus 5, or 5. And then we divide them. So 1 divided by 5 is 1 over 5, or 0.2. Now we're going to scroll down. I'm going to add one here too. And we're going to do the same thing, except for here, we're not getting a number. We're just being given x. All that means is you plug the whole function in. So we're going to take all of f of x and add it to all of g of x. So f of x is 8x minus 9, and g of x is the square root of 2x minus 1, and then we add those together. Now for this, there's no like terms. There's nothing to combine, so we'd stop there. If we had f plus h of x, which is that one I just added over here, we would do 8x minus 9 plus 3x plus 1, then combine like terms. So 8x plus 3x is 11x, and negative 9 plus 1 is negative 8. And that would give us this function. So you still have to do your combining like terms into whatever you need to do. So subtracting would be the same thing with our f minus g. 8x minus 9 minus square root of 2x minus 1. Again, can't do anything past that. So let's try our f minus h. So that's going to be 8x minus 9 minus 3x plus 1. Now I put the parentheses because we want to make sure we subtract both parts. So we're going to distribute that negative sign. and then combine like terms. So 8x minus 3x is 5x. Negative 9 minus negative 1 is negative 10. Same thing with our multiplying. 8x minus 9 times the square root of 2x minus 1. Now we could distribute out that radical, and then we'd have two radicals, so it's better to keep it that way, just for looks purposes. But again, if we did it with one that is multipliable, I guess, we could end up foiling this. So we would do first times first, outside times outside, inside times inside, last times last, and then combine our like terms. So this would be minus 19x, and that would be that equation. And then lastly, our f over our g. So we would take f, we put it on top of g. There's no simplifying that would make that pretty, so we'll stop. And then if we did f over h, it would be 8x minus 9 over 3x plus 1, which also there's no way to divide that and make it pretty, so we'd stop there. So those are your operations. Now we're going to review back to what we talked about a little bit ago, a couple sections ago with domain. And anything that's just a regular equation with no radical and no fraction is going to be negative infinity to infinity. So this one, negative infinity to infinity, because we have no radical, no fraction. Same thing here, same thing here. For the rest, we have to do some calculating. So for this one, the 8x doesn't tell us anything. The 9 doesn't tell us anything. All that affects our domain is that radical. So 2x minus 1 has to be greater than or equal to 0 because it's a radical. So we'd add 1 to both sides, divide by 2, and we get x is greater than or equal to 1/2. If you like the interval notation, you can write it like that. That's going to be true for the adding one, and the subtracting one, and the multiplying one, because the only thing in all three of those limiting our domain is the radical. The division is slightly different because it's also on the bottom of the fraction. So that tells us that it can't equal 0 either. So in this case, it would just be x is greater than 1/2 because it can't actually equal the 0. For the fraction down here, we would just say 3x plus 1 can't equal 0 and solve that. So we would subtract 1 from both sides, divide by 3. So x cannot equal negative 1/3, which in interval notation would look like this. So again, when you're finding your domain, you only have to do any calculations if there's an even radical or a fraction. We can also do our function operations with a graph. You just find the value of that function on the graph. So we're going to call this f, we're going to call this g. So f of 4, we go to 4, go up to the point, our y is 4. G of 4, we go up to the point, we get 2, and then we add them together, so we get 6. Now let's look at negative 2. F of negative 2 is negative 2. G of negative 2 doesn't exist. G stops here. So since it doesn't exist, we can't do it. There's no solution. That's an okay answer. Let's look at f of 1. F of 1 is right here, so it's 1. G of 1's in the same place. 1 times 1 equals 1. And then let's do the last one. F of 0 is 0. G of 0 is 0. You can't divide by 0, so this is also no solution or undefined. So as long as you understand the function notation, then these just tell you exactly what you're doing. Let's look at a couple more. So if we go over here, we have f of x plus h. So this is saying plug in x plus h for f and then simplify. So if I did this one, I would rewrite x squared as x plus h squared. Squared means you have two of these, and then we'd FOIL. So x times x is x squared, x times x, or x times h is xh, h times x is xh, and h times h is h squared. Combine like terms, we get this. If we did the same thing over here, again, it's the same process, it just has an extra term. So we would start by saying 2 times x plus h minus 5 times x plus h squared. Now we just did this over here, so I'm just going to transfer that. So in x plus h squared was x squared plus 2xh plus h squared. Now we'll distribute our numbers. So 2x plus 2h minus 5x squared minus 10xh minus 5h squared. Now it looks really yucky, but it is what it is. That's how they're written. So that's your function operations. And just a refresher of evaluating function notation. Now we're going to do what we call composition, or FOG. It's read as f of g of x. If you're given a number, you work inside out. So you would plug the number into g, and then whatever you get, you plug into f. So if these are our f and g here, first we're going to plug 2 into g. So g of 2 is 4 over 2 minus 1. 2 minus 1 is 1. 4 over 1 is 4. Then we take that 4 and plug it into f. So f of 4 would be 2 times 4 minus 1, which is 8 minus 1, or 7. This one says Goff. So the difference is we're going to plug it into f first. So f of negative 3 is 2 times negative 3 minus 1, or negative 6 minus 1, or negative 7. Then we're going to take that negative 7 and plug it into g. So g of negative 7 is 4 over negative 7 minus 1, or 4 over negative 8, which reduces to negative 1/2. So the FOG, or the composition, just has you doing something to one and then the other instead of the same thing to both. And when we get down here and it doesn't give us a number, it's just saying plug that whole function in. So we're going to take f of x and put it in wherever g is. So g is 2x squared plus 5x. Now wherever we see x, we're going to put f of x. So 4x plus 1 squared, and then 4x plus 1. So first, we're going to expand so that we know what we're multiplying here. Then I'm going to FOIL those parentheses. So I'd have 16x squared plus 4x plus 4x plus 1. Then I'm going to distribute. So 32x squared, 8x, 8x, 2, 20x, and 5. Now I combine like terms. So we have 32x squared, and then 8 plus 8 is 16, plus 20 is 36, and 2 plus 5 is 7. So if you're not given a number, you're still going to end up with your equation there. So let's do one more just to make sure. Inside out. So this one's saying plug g into f of x. So f of x is 4x plus 1. So instead of 4, instead of x, I'm going to put 2x squared plus 5x. then distribute. So we get 8x squared plus 20x, and that 1's outside, so just plus 1. So that is our composition of functions. So that is section 3.4. You're more than halfway down in chapter 3.